Hello, everyone. I would like to welcome you all to the APRU Sustainable Waste Management Global Lecture Series. I'm Pavani Disanayake, a PhD scholar at Korea University, and I'm going to host this event together with Professor Oak. Before starting today's event, I would like to invite Paul Park to provide some technical instructions to the webinar logistic for the attendees. Over to you, Paul.
Hello, everyone. Thank you for being with us for the 6th session of Global Lecture Series. As Pavani has mentioned, I'm going to collaborate with the webinar logistics today. I would like to give you some recommendations to be considered during the event. This is a webinar mode, so you can listen and see the panelists and is able to interact through the following tools. We have enabled 2 chats. You can ask questions to our speaker or panelist anytime through Q&A chat and on the general chat. You could leave comments or share important information. If you're interested to talk and ask a question, please raise your hand and I will unmute you so you can interact directly with the panelists. As it is an international event, we kindly ask you to use the English name all the time. Besides, if you have any problem or issue during the event, please feel free to send a chat to me and I will try to help you. We hope you will enjoy the event. Thank you so much.
Thank you, Paul. APRU Sustainable Waste Management Global Lecture Series is organized by the APRU Sustainable Waste Management Program, where Professor Young-Sik Ok at Korea University serves as the director of the program. The program is co-directed by Professor William Mitch at Stanford University and Professor David Waddell at Nanotechnological University. Today's lecture will be delivered by Professor Jin Nguyen from Royal Institute of Technology in Sweden. The title of the lecture is Energy Systems Transition Towards Carbon Neutrality. At the end of his presentation, there will be a Q&A session. I encourage all the attendees to participate in the event actively and come up with your questions for the discussion. Now, I would like to invite Professor Young-Sik Ok to give the welcome address. Over to you, Professor Ok.
Hey, thank you, Pavani. Hello, everyone. I'm Young-Sik Ok, who is a director of APRU Sustainable Waste Management Program and chair of this session. As you may know, APRU has a membership of the president of 60 leading universities from around the Pacific Rim region. And this includes more than 2 million students and 200,000 academic staff. So APRU Sustainable Waste Management Global Lecture Series is designed to provide a sound foundation in basic principles and unifying research across ecology to conservation and environmental health to waste management, while paying more attention to ESG and global sustainability. Particularly, some selected topic will be discussed through APRU Global Lecture Series. And the key topic of our lecture series are environmental science, global sustainability, sustainable waste management, life cycle assessment, and life cycle sustainability assessment, and carbon neutral, and so on. So as you may know, our program has consistently tried to carry out a variety of programs designed to accelerate academic activity and international cooperation. So our lecture series is a part of regular range of events offered by APRU Sustainable Waste Management Program, and is designed to offer audience an inside view of cutting-edge research topic. So I believe the participant will be able to learn from and interact with world-renowned scientists around the world through this lecture series. I hope that this event will become a valuable opportunity to extend and share friendship among those who participate in this webinar. And I especially thanks to Ojung Resilience Institute at Korea University, to our institute director, Professor Yu Kyun, for his strong support for our lecture series. Thank you very much.
Thank you very much, Professor Ok. Now we will move to the 6th lecture of Global Lecture Series. I would like to invite Professor Chung Gu from Nanjing University, China, to introduce today's speaker.
Thank you, Paul. So it's a great honor for me to introduce our speaker. So I'm Chung Gu from Nanjing University, who is Professor Jin Yang from Royal Institute of Technology, Sweden. Before starting this lecture, I would like to give a brief introduction about Professor Yan. Dr. Yan is a professor of energy engineering, Royal Institute of Technology, and the Mälardalen University, Sweden. He's also a director of Future Energy Profile, editor-in-chief of Applied Energy, editor-in-chief of Handbook of Clean Energy System. He is an active member of European Academy of Science and Art. Professor Yan received his PhD from KTU in 1991. During 2001 to 2005, he was a chair professor and the head of energy engineering at Luleå University of Technology, Sweden. Professor Yan's research interests include simulation, optimization of advanced energy systems, renewable energy, carbon capture and storage, clean development mechanisms, and fundamental engineering, thermodynamics. Professor Yan published over 400 papers in major journals, including Science, Nature Climate Change, and ASME, Mechanical Engineering. Professor Yan, so it's next, so over to you. Thank you.
Thank you, Professor Go, for the introduction, and thank you very much, Professor Oak, to invite me for the lecture. The title is, as mentioned, is energy system transition. I changed a little bit with remove the system because it's more linked to the even larger, in general, topics, energy transition towards carbon neutrality. In fact, there are a lot of challenges, and at the same time, it's an opportunity for our scientists and engineers to tackle the challenges. So this is what I'm going to. It's very light topics. I don't think I can cover everything, and maybe just cover part of and which reflect to what I feel was energy transition and for the future, and in particular for the research challenge faced to us. And as mentioned, I have been working in different universities in KTH, at the Royal Institute of Technology and the University of Technology, and also the Mälardalen University, which is it's a little bit difficult to say, because in Swedish but the Mälardalen University is in fact is one located in the city of the Västerås. Is we call the capital of energy in Sweden. And the reason because surrounding industry and many energy related company are there. Is in fact it's more than in Stockholm, which I'm living here. At the same time, I'm working a little bit part as my hobby as editor-in-chief in Applied Energy, all junior, and also a new one we just launched 1 year ago called Advances in Applied Energy. So there might be some author and readers, and also many people help us to support the journal development. And one so-called energy platform, Future Energy Profile, is the joint kind of the research platform, collaboration with industry and also the government, and also the Swedish Knowledge Foundation. So this is what I'm working and together with other colleagues. And we back to the topic, we're talking about the carbon neutrality or zero emission. And
I'm sorry to disturb you, Professor Yan. Could you please share your screen?
I have shared. Okay. Sorry. Let's see. Can you see it now?
Yes, now.
Okay.
Yes, thank you.
Good. Other words, this is just like the 2 slides. Is just some kind of introduction about me and also our institute. So this is the first slide. We're talking about the carbon neutrality, and it's in fact, it's linked to the zero emission. And you do see different kind of country in different kind of stage. If you look at national strategy or even place into the law. So those are the picture which you can see is 2019. And a little bit the change, which has a more country involved into this carbon neutrality, in particular a larger country like China announced last year for the carbon neutrality in 2060. And the different country has different strategy, and either in the legal phase or put into the, but those is in fact is one of the strong background which link to our energy system transition or energy transition. And because this is kind of new constraint or the constraint which has been placed today or in the future. But look at carbon neutrality, I would like to use a little bit of time to look at the history of what has been happened. Take one example, Sweden, which I'm living now. If you look 1970s and look left side, Swedish energy mix, in fact, you can say it's a very fossil fuel based society. And the energy in particular, the oil, plays a very important role for supplies the whole country. And it took roughly about 14 years. And today's situation is the renewable energy is more than 15%. And that's why I use this kind of data to know this has been used for many years ago. Why I discuss about the carbon neutrality or the low carbon society. Many, we get a lot of questions because we are rely on the heavily fossil fuel, and they don't believe will be changed. Such a transition might be difficult. And this is why I show this picture. It takes 14 years. And if we go back to the 1970s, us Swedish, and if it's possible to change society from heavily more than like 70% or even higher oil-based society to today's situation, more than 15% renewable energy, might be, you got answer might be no. But similar, we ask the same question to some kind of today's situation in some country, and which are fossil fuel based. If it's possible, take 13, 14 years later, we can change society to be a more or less carbon dependent. So this is one question, but how this has been happened, in fact, you can say, in addition to the energy mix, which have been changed, introduced nuclear, biomass, and other renewable energy. And so those is a significant change. And also in the industry and the society and the residential transport sectors, energy efficiency also plays very important role for such kind of change. So I would like to say the energy transition, we're talking about the future. In fact, this has been happened. Another question raised is emission reduction or low carbon or even zero emission. People will think about this is linked to the negative impact to the economic development. And this is another diagram shows Sweden if it takes 1990 as a 100 as the index. And the emission has been reduced 26% to 2017. And the GDP has been increased 78%. So decoupling of the economic development and the emission is possible. So those are the facts which has been happening. So the carbon neutrality is involved a lot of change, but such a change, in fact, is not necessary to bring the negative impact to the economy. So it's possible to develop the economy at the same time, mitigate the emissions. This is Swedish future. If you're talking about the carbon neutrality, the target, if the time scale is a long-term target, is to net zero emission in 2045. You know, most of the country are in 2015. That's linked to the Paris Agreement. And but Sweden has put 5 years early. And then you say if you divide the target into different kind of milestone, it's 2020 with 14%, 30 with 16.3%, and 40 with 17.5%, and 14.5 with 0. So this is based on the 1990. That's a Kyoto baseline. And the transition I'm talking about, in fact, it has been happened, is the future is now. And I just mentioned about what had been happened in Sweden. And if you look at other European countries, you do see the many, there's a coal-fired power plant under the phase out and with a different kind of schedule. And in fact, I borrowed this slide from a professor from Germany. And he was giving a keynote in our conference in the last year, International Conference on Applied Energy. It really shows decarbonization is already involved into our economy, and the future is now. And back to the energy system, and pursue such a kind of change will involve a lot of transition. And if you look at the traditional system, you take electricity as one example. We have supply and demand, which is balanced. And traditional system is electricity is supplied from central power generation station and through transmission supply to the end user. As a one way, one direction approach. And what has been changed is one is from supply side. This link to the renewable energy penetration. And also the supply side, demand side involved a lot of distributed energy, such as the solar wind can be implemented in the demand side. For example, our building roof can be potentially used for solar PV electricity generation, and also involve a lot of demand response, and our user behavior will change the whole system. And also the storage, not only utility storage, larger storage, and also distributed storage. And such kind of change will place into our traditional energy system, which will affect the whole system, not only one way from supply to the end user, and also the end user might be involved into the whole energy system. In such a kind of change, I would say, involves the renewable energy and demand side, change the existing balance. So we do need a dynamic balance to handle the variable renewable energy, versus such a renewable energy is not similar as the conventional fossil fuel. They are the variable. And also we need to involve into demand side, and also need storage to be linked into the system or integrated into the system to be able to keep the whole system into another kind of dynamic balance. So this is what we call the dredge. In fact, it's one of the important challenge we have faced, and I would also say it's one research question, a larger research question, placed to our energy scientists and engineers, how to handle the variable renewable energy, how to integrate the storage and also demand side. So our future energy system is already now. We will still want to have the efficient and secure system, but one added into the flexibility, and to have, as mentioned, to handle the dynamic balance, which link to the variable renewable energy, and also many link to the new research topics, such as the grid, how you integrate, have a better or smart grid, and how to have the flexible generation, and how to integrate the energy storage and the demand side response. All those, if you look at the publication and also the application, and there are many new studies and the development which have been linked to the flexibility. I would say flexibility is a new KPI has placed into our energy system, and in addition to the efficiency and the security. So this is the new thing we need to handle from the technology point of view, from the new business model, and also from the other integration of the system. So this is one project we call Flexergy, which we are working on. The diagram shows the different aspects. Its synergy is very important to link to the whole study. And the synergy, for example, with how we handle the spatial and the temporal projection and supply of the energy load and also supply. And how to develop the new business model, because the flexibility involves a new opportunity. And we do need a new business model to involve all different stakeholders to share the benefit and at the same time overcome the difficulty. And such a kind of system become more integrated and larger complex. And we do need a lot of data. So data-driven model and management to handle the flexibility and become more important. So those three aspects, in fact, is our this larger project. The project has been involved in more than 10 different kinds of industry partners, and together with three local governments, and we try to identify the new opportunity and for the local government and also the local industry to be implemented into the urban scale system. So it's the urban energy system, and in particular handles the flexibility for the future energy system. So as I mentioned, we need to handle the dynamics. We need to handle the variable renewable energy. We need to integrate energy storage and also demand side. Those are the different aspects. I will go through the talk with different aspects, give some examples. And let me bring the conclusion message first. And I would like to stress and few things about our energy system. One is the energy system is in transition. In fact, it's now. And particularly we need to handle, and we need to think about the variable renewable energy penetration and together with the flexibility of the system. And our system has become more from the resource-based, because that's fossil fuel-based. We need to think about the resource, limited resource, and to be more system integration. And the resource can be free, but not available all the time. For example, like solar, wind. And that's why system integration become more important. And the third one is our system is more local dependent. So we need a tailor-made innovation rather than more general solution. The reason is simple, because user is the local dependent, and also the supply is also very local dependent, like solar, wind, for example. So those are the key message I will, how to keep the balance. That's the not only technology and also the art, and which is what we are working on. The first is related to the flexibility associated with the higher renewable energy penetration. And there are different kinds of solutions. We need to handle the dynamics. We need to handle smart integration or interaction with the consumers. And we need to handle the renewable and the variable renewable energy and the storage. And those are three aspects I would like to discuss a little bit more. Regarding the dynamics, as I already mentioned, our energy supply and in terms of the renewable energy resources become more local dependent, and user always local dependent. So we need to understand better spatial and temporal characteristics. And in such a way, we need really working more new tools, and which can be linked to the other field, in addition to the not only the energy studies, for example, like GIS, Geographic Information System, IoT, and also ICT, Information Communication Technology. Such kind of data-driven models and measures are more involved into our energy studies. We need new mapping tools to understand the spatial and the temporal situation of the resource and also the user load profiles. And we need to develop new methods to validate the modeling and the data. And also we need a better database to organize such kind of data. All those different aspects, in fact, have been involved into the energy studies. This is one example. We try to identify the roof potential. And there you need to understand the different kind of shape of the roof. And you need to have the good image to understand if it looks in a larger area. And such a current image might be, you can use satellite image from Google Map or some other database. But in some of if the image the quality is not good enough, we do need to use other new tools. For example, this is we use a closer video camera to have the image of the roof in our. This is one example of our campus library building. And so there is a lot of different kind of tools and different new approach which apply to this kind of potential renewable energy electricity generation, for example. And then you can use the mapping to the different areas. This is one area we have been working on near to the Westfield city, and looks at different kind of roof, different potential. And this is one example. And in order to understand the different geographic information system and the local condition, one example was this paper published in 2000, about nearly 1.5 years ago in Nature Energy. In fact, it involved 344 cities in China, and we looked at the local solar radiation and also the local electricity price to understand how subsidy-free solar PV electricity can compete with the fossil fuel, and what's the competitiveness in terms of the economic and the cost issues. And we introduced the so-called grid parity index, and those can be used either the electricity price supplied to the grid, so we call it, or use the electricity price as a user side. And very interesting results which we have achieved. One is if you look at the user side, the electricity price can reach the 100% of the grid parity, which means in fact, in any place, PV can compete with the traditional fossil fuel-based electricity if based on the user side the electricity price. Of course, there are different kinds of situations. We didn't discuss more detailed about the local situation if electricity can supply to the end user. That's another issue which is beyond the technology and rather than policy and the local other energy policy and also the grid access issues. And however, if you look at the electricity price as the similar price as the coal-fired power plant supplied to the grid, and the results are a little bit different, but still we have about 1/4, around 25% of the city which can reach to the grid parity. That's if you look at the next figure, it shows a little better. And the bottom shows the different kinds of cities. And if plus means the PV generation can reach to the benefit, and the minus, which means it's lost money. And you do see the yellow color, which covers the situation for the scenario for the user side. User side electricity price, you can reach 100%. At the different city might be the benefit different. However, if you use electricity to make access to the grid, and which can be different. Here you show some of the country has a benefit, and there are not some of city, and some city has a negative profit, which means you do need more either subsidies or stimulate market for the penetration of the solar PV into the local market. But again, you show the very important conclusion. Renewable energy, we take the PV electricity generation as one example, is not the alternative energy, rather it's become one of the mainstream energy. So this is a very important message which we can bring through this study. And such a kind of change, which is significantly linked to the, I'm sorry. Significant link to the cost reduction. And this is from the.
Sorry, Professor Yang,
yeah.
I cannot see your screen.
Okay. Disappeared with the screen share.
Oh,
Up now?
Yes, it works. Thank you.
Yes. The significant reduce of the cost, levelized cost of electricity, for example. You do see a lot of cost reduction from the renewable energy. Some of the little bit increase for the geothermal and the hydropower may be linked to the environment issue, as Professor Oko has mentioned about the life cycle assessment, which is we need to think about more like impact with the environment. And however, so most of the renewable energy has been involved significant reduction of the cost. First of all, like in particular solar and wind. The green part is the fossil fuel the cost range, which is you do say the renewable energy already into the range which can compete with the fossil fuel electricity. And this is one result we have been working, we have studied for the China situation. Even you depend on the different kind of assumption, and you do see the significant reduction of the over the time with the cost of electricity. There are some other data you can see. This is DOE data. It's a real project cost. It's very interesting. You do see that if overall cost of reduction of the electricity generation over the years, every assumption like every 2 or 3 years, you come to the half of the cost. And in particular, if you look more carefully with the hard cost reduction, and if you include the installation cost into the hard cost, those things really shows a significant reduce. However, one thing I would like to bring the people to attention to the soft cost, which link to the PI, sales tax, overhead, and of course net profit. And this part, in fact, is reduced a little bit. However, as a percentage of the soft cost, in fact, increase. And this is brings a very important issue in the future, and how we can go further through the technology innovation to reduce the hard cost. However, very important to involve into the other stakeholders to reduce the soft cost, because if we reduce half of the hard cost, which might be only about 14 or 13% of the total cost reduction, that means that if it divided by 2, that's roughly 15% total cost reduction. However, if we don't have the new system innovation, which can really result in the soft cost, that would be very difficult to reach even lower cost for the future. So this is brings one very important research which need to involve into the economics and even social scientists, how to involve reduce the soft cost. And if you look at renewable energy penetration is indeed has been significantly increased. However, if in terms of total renewable energy compared to fossil fuel, is still not enough. You do see it's a different kind of development. For example, like China has been increased significantly for the solar PV installation, but at the same time there's a coal-fired power plant, new coal-fired power plant even installed in. So this is a competition of the renewable energy and the fossil fuel, not only based on the situation in the past and also for the future. And so that's one very important issue need to be considered. And talking about the renewable energy, in which we have been involved different kinds of studies, and many has the utility PV, for example, wind placed into the very larger farm and takes a lot of land. And I have one idea, so if it's possible to integrate with renewable energy in the existing infrastructure, and such kind of infrastructure normally involve a lot of electricity load too. And this will be place the renewable energy closer to the end user and to make the electricity or renewable energy access rate a little bit higher. And one example, like coal-fired power plants, this is the left picture. And we have studied about 1,000 different kind of coal-fired power plant, and we do identify a lot of potential which can be used. Use China as an example, and we look at the different kind of power plants and look at the location, and you do find a lot of area like roof, and for example, this area like this is a coal storage, and if we do some modification, it can be also used for the PV production. And such kind of electricity will be very easily integrated into the existing system, and because it's close to end user, and there are other all the grid access which is easy to be modified and accessible. And we also studied like highway and also railway high-speed train along, for example, Beijing, Shanghai, and different kind of infrastructure. And you do see a lot of potential. I believe those kind of potential, if we study a little more into the other, like steel mills, pulp paper mills, chemical, petroleum, and some other existing structure, I believe this potential would be higher than the existing installed renewable energy. Because we just take the coal-fired power plant, it takes roughly more. The potential can be half of the China installed PV capacity, which is really shows a great potential. Such kind of the solution might be even cheaper because you avoid land use or limited land use impact and close to the end user. So the economic benefit could be even better than the larger utility scale, for example, PV or wind power. As a second question relate to the smart integration to the end user. And there are a lot of new technology development and has been promoted to involve the consumer to be a producer, so-called prosumers. Many discuss and study on the microgrid and distributed energy system and demand side response linked to the load shifting and peer-to-peer integration and or trading and the flexibility bidding, except some other like a new business. I will give one example here to show very simple. I wouldn't say it's a technology, it's a solution because it doesn't involve any change of the doesn't involve any change of the whole system. There are no new installation. This is a flexibility service provided by the building thermal inertia and using the existing building as the thermal energy storage. This project has been working with Gothenburg Energy It's a second largest city supply to the energy to the city, the Gothenburg Energy Utility Company. If you look at the curve, this district heating curve, the red one is the existing. You do see the peak here. And if you use a flexible, kind of use our building as to change the control strategy. For example, if we can predict the peak load, we heat the building 1 degree higher. And then during the peak load, and we lower the supply temperature 1 degree lower. In such way, we change the supply curve to the blue one. And this means you do see the more flat the supply or load curve, which is save about like the total cost around 15% for the supply side, means district heating company. But we calculate a little bit more carefully and look at the end user. And in fact, because the end user has been charged by the thermal energy and total amount how much energy you have been used, and in fact the increase roughly 4%. And you do see that we do need a new price model, a new business model to handle this, because the traditional model will give 15% of benefit to the supply and the district heating company, but the end user will increase 4% of their thermal energy or district heating bill. And that's why the share should be better, benefits should be better shared between the supply and the utility company or district company and end user. So this is why it's not only the technology need to be developed or new solution developed, need to new business model. Taking the e-vehicles as one example, we are talking about fast charging and how to make the electric vehicle to be better used for the end consumer. In fact, the e-vehicle can be used as a mobilized energy storage if looked from the energy system point of view. And this controlled charging plays, in fact, a very important role for the future, and how this can be linked to the vehicle to gas technology. And also the link to the electricity grid, V2G, in fact, vehicle to grid technology. And such kind of change, if we call the control change, you do able to change the load profile too. We are working on the similar concept. Look the use Sweden as one city as one example. Look how this controlled change can change the future grid flexibility, how the electric vehicle can contribute to from the flexibility point of view for the whole system. And personal behavior and end user behavior is also very important. This is one of the study of my postdoc. He was in Tokyo University, which working on the personal behavior and to use the different kind of mobility data to modeling how the personal behavior can be potentially changed. There's one paper has been published in, I could remember, this might be advanced in applied energy, which we studied the mobility change, which can link to the future emission and also the energy system. And the third one, how we integrate the variable renewable energy and also storage, which a lot of has been linked to technology development. For example, like storage development has been very much attention by different kind of developers and also scientists. I'm sure storage will be very hot topics, and it might follow the same trends as solar PV and wind will significantly reduce the cost. That's the link to technology development. But what I'm trying to bring more important for the linkage of the different kinds of sectors. And in addition to the traditional technology development, also pay attention to the water storage and the power to X, which can link to different kinds of sectors. I take power electricity sector as one example. And of course, to increase the flexibility, we may need to introduce the energy storage, and this can be linked to the utility central energy storage or distributed at the end user side as distributed energy storage. It's also very important to couple to different sectors. For example, heating sector, I just mentioned about this one load shifting, and it can be linked to the power and heat, and which how these two different sectors can be coupled together, and can link to the transport sector. For example, like use EV as a potential mobilized energy storage, and the water sector is water treatment and fresh water making, and it take a lot of energy, and the load shifting is possible to integrate together with the utility and together with water sector. And the data sector, in fact, I feel is more interesting because energy storage and transmission normally involve larger cost and losses. And however, the data transmission and also storage become much cheaper. And for example, we are able to do this kind of video lecture because we have very little barrier regarding the data transmission and also cheap. And however, if I supply 1 kilowatt hour electricity from Stockholm to your city, I'm sure it's you got very little. So this is why it's possible to do the data shifting for the load shifting to link to the electricity shifting. I believe this is a very interesting potential area we might be able to explore. And we do have some kind of study and some students working on this area, but it's not enough. I really hope can involve more people, in particular working with the larger data center, and they understand better with the data load and to look if electricity load shifting can be linked to the data load shifting and to change the energy supply or demand profile. Those are some examples we have been working with the European Commission, so this EU project, and we took different kind of use case. And as mentioned, we do need to develop the local tailor-made solution. For example, Sweden has a lot of discrete demand, so the combined heat power become very important. And Italy could be another situation for the during summer. We don't have air conditioner, but Italy has a strong demand in the cooling demand. And Denmark and the UK can be different. And for example, UK has a gas system and integration with national gas grid can be more important. However, for example, like Sweden, we have very limited gas grid. And similar like Denmark is a quite different energy mix from that. Denmark, they have a lot of the wind electricity generation, and such a link which can be very important and local different solution, and which can develop a more so-called use case and can supply some best practice and to show how to handle the different situation under different conditions, in particular local conditions. Okay, this is my last slide, and the conclusion I already mentioned. Our system become more integrated and interconnected, but not necessary to be a larger system. There's a lot of there are some discussions talking about the Internet of Energy, which means we want to have use a simple energy system to be enlarge our energy system, but the energy system should be more distributed and local dependent. This is different from my point of view. And a local dependent system, we need to handle local variable supply and the load, and how to involve the consumer to be a producer, to change into the prosumer is very important, because our system is not only as a traditional old system, which we supply determines the features, and also end user has been more involved into the whole system. So those are my conclusion, and I believe this is the last slide. If yeah, there's I would like to mention about Applied Energy, and just do some little bit PR and for those two journals, and we have involved more than 15 scientists from the author or reader point of view. So from the over 120 countries, and you are welcome, of course, submit your paper to either Applied Energy or advances in Applied Energy. Thank you. Any question?
Thank you, Professor Yan, for your very comprehensive presentation. I enjoyed your presentation a lot, and also thank you for sharing information for the Applied Energy. We all know the upcoming conference, and we are planning to be actively involved in. So the Q&A and panel discussion will be led by Professor Chi-Ha Wang from National University of Singapore. So Professor Wang, are you there?
Yes, thanks very much, Prof. Oak, for your introduction. So welcome to the Q&A session. Actually, in the chat box, I can already capture some question. So actually, I'm not sure whether the participant can speak. So probably for the first question, so I think I will read out the question from the box, right? So the question from Xiaoming Dao. So the question is as follows. It is not sure the effect of V2G two-way charging to the lifespan of the electric vehicle battery. So can I check with Prof. Yan for a possible response to the question?
So I didn't get to very clearly for the
sure.
P2G.
Yes. So the question is basically it is not sure about the effect of V2G two-way charging to the lifespan of the electric vehicle battery. So the question is from Xiaoming.
Okay.
Yeah.
Okay. Yeah, it's in fact this is a very new area. I'm not working in particular with battery and storage in particular. We look at for the whole system point of view, and I'm not sure if it need to be two-way of charging. If we're just changing of the time of charging can significantly change the situation. Of course, it's might be that's a link to the more even the future technology development to have a two-way. Even the car become like really like a storage. What I'm thinking about, you change it off your time of charging. In fact, already so-called controlled charging, and without you still the vehicle is still vehicle. You need to meet the need of the mobility, but just additional benefits. For example, you're charging during the night and when the off peak, or during the daytime when you have a high peak of the renewable energy in the future. But how to handle this? This is you should not only look the vehicle itself, and you need to be linked to the whole system. That's number one. Number two, how you send the signal to the end users. The end user will not consider, oh, now you are in the peak load, I will not charge. And rather than if during that time the electricity become more expensive, I can wait for 1 hour to charge, and then they may. So that's another when we need to handle the price model and the new business model, and also infrastructure, how those kind of information can transfer to the end users. Versus if you are in, I don't know why I should working together. If I should now do what's my motivation, that's linked to the business model. That's something which I feel. Of course, in the future is a new charging mode, or even the two-way of charging, or charging, recharging, and that can be. I haven't think about that part. That could be more interesting for the future development.
Sure. Okay, thanks very much. So So we have the second question from Kyunam Kim. So the question is regarding just briefly mention hydrogen in your presentation as one of power 2 times. Except for renewable energy, how do you think hydrogen energy, nuclear energy, and the CCUS will become key source to reach carbon neutral in the future? Your opinion, please.
Hydrogen, let's talk about hydrogen. Hydrogen, in fact, is old topic. It's become hot again. It's not, I would say it's about 10 years ago. And we have a discussion about hydrogen economy. And for example, Iceland talking about the whole country to be hydrogen as a new energy carrier. And so this is the second wave of hydrogen become more hot topics. I would like to say this is a link to the renewable energy penetration. And the reason because when you increase the renewable energy penetration, as mentioned, we need to handle the flexibility. And in fact, we need the storage. I look the hydrogen become more important for the long-term energy storage, and rather than energy supply or as an energy carrier. And if you look 10 years ago, there are a lot of discussion about hydrogen or electricity. So we use hydrogen to replace the electricity as a new energy carrier. That's the discussion which had been we had before. But I would say hydrogen is more linked to the energy storage and linked to the flexibility issues. In such a way, hydrogen become more important and not as the energy resource, rather than how to handle the flexibility and energy storage, and then how to use those electricity from renewable energy, which will be not able to supply anywhere. Curtailment of electricity, so-called renewable energy, that can really generate those green hydrogen. So that's a very important part. And of course, there are a lot of discussion. Hydrogen today's situation is still based on fossil fuel, but think about the future. And we are in the energy transition, and it can be from this kind of green hydrogen to be a green hydrogen, and even maybe there are bypass into blue hydrogen in the middle. And then the CCS linked to the if we still need to continue to use fossil fuel, and you need CCS. And then the cost, and so far it's maybe CCS around $15 per ton of CO2 in terms of cost. Of course, there are some situations could be cheaper and could be more expensive. And so there you need a good carbon price. And if you look at the European emission trading scheme, and the carbon price reached to more than 15 euro, which is good stuff. And I believe even higher carbon price could be stimulated. And if it looks the whole economy, it should work. That's if we want to continue to use fossil fuel and carbon capture storage, that's one way to even talking about the negative emission, for example, bioenergy with the CO2 capture and storage. In fact, the BECCS. I'm the first person to introduce this concept in the world. If you look at the history of the publication, it's my PhD student. I'm working with the bioenergy system at CCS. So that's even those more other way linked to the carbon capture and storage technology development. There another question about CCS, hydrogen, and is that all or?
No, we still have a third question here from He Xin. So the question is, thank you very much for the great presentation. I would like to ask about the reliability of the smart system with large amounts of renewable penetrations. For instance, there was a power crisis in Texas, and it was partly blamed on frozen wind turbines. Will the proposed system be helpful for those extreme conditions?
Yeah, it's very interesting. The Texas, I would like to encourage you to read the recent publication Advances in Applied Energy, which is just published about Texas electricity price, and which had been studied by Professor Xie Le. He is a professor in the Texas A&M. There is, as mentioned about when have variable renewable energy involved, our system will still need to efficient, secure, and flexibility. It's more difficult. That's challenges. We talk about energy transition or energy transition challenges. This is the challenge we have to face. And that's similar to any system. When you introduce new things, security will be somehow reduced a little bit because it's new. But that doesn't mean in the future cannot solve. So this is very important. We should understand the reason and the results. And Texas is a little bit, I haven't studied carefully, but I don't first just say, oh, because renewable energy makes a system like situations. That's too simple to conclude in such a way. And if it's changing, always involve the risk or unsecure. But if you change it better and you improve the security and in future, the system become better. So that's always we are doing something like that. But again, it's a variable renewable energy. Security become more important. That's why it's a lot of study that has discussed. If you look at our recent publication, it's not only, which has not been so much publication before, regarding the reliability and the resilience of the whole system. And the reason because we have variable supply and variable demand. And the whole system dynamics has been significantly changed compared to what we had before. But such a change we need to face. But we shouldn't say we don't want to make such a change because we have to make change. And that's different things. So this is they're talking about freezing wind turbines. In fact, there can be happened anything, even some other extreme weathers, and you do see a lot of different other situations happen. And we do need to increase the security, but this is can happen when you have high renewable energy. How to increase the in fact, even fossil fuel similar. As for example, it's happened in China like just 10 years ago with the freezing of the grid, which you have strong. That's you can see because extreme weather and the electric grid cannot supply the electricity, and that can be happen too. So that's any system can be happen, and of course the component involved in renewable energy, if those kind of component has some of those issues like the wind turbine freezing, and you do need to consider how to handle it. For example, like if it takes Denmark as one example, they have a larger wind penetration, not only reliability and also flexibility, but they do have the supply system like hydropower from the Norway and Sweden. The Nordic pole, somehow this pole has placed very good flexibility adjustment, or this is one, if Denmark is an isolated country, it will be very difficult to handle without this kind of the hydropower from Sweden and Norway. So that's why the system needs more integrated and interconnected.
Sure. Okay. Thanks very much for the answer to the above three questions. So I think our final question for the session will be that from your presentation for your past publication in Nature Energy. So you talk about the assessment of 344 prefecture level cities in China. So our curiosity is how to compare data. So how to compare the big data when so many cities are involved. So I think the methodology for the data compilation appear to be very challenging. So hopefully through this Q&A session, so we can hear some of the experience of monitoring this kind of big data project.
In fact, this is this idea it came from that's 2019. If I remember, that's 1st of May or 1st of July. I couldn't remember which month. They trying to introduce a new policy, so try to phase out all subsidies. and it introduces significant turbulence for the whole sector, including developers and scientists and manufacturers. All they have different views. That's how we raised this question to do so. Then I discussed with my students and postdoc and other colleagues. Say, should we do a study? Look at what's the real situation without subsidy, and that's how we started. And then it is the data. In fact, it's not only this study. In fact, all other studies involve a lot of data, which is not the data availability and also the data privacy, even more difficult to handle, in particular in Europe. And for this situation, we did a different kind of way. One is we look at all this kind of database and statistics, but very important, we look at the different local cities as a city level, because this is very important. And we use the national data, and at the same time we do the validation. And that's how we're working with different city locals, even those local consumer. What's your electricity price? And to the access to the grid electricity price, that's okay. It's for that's national grid is more regulated electricity price, but the end user price. That's why we if you look carefully, we look at this as a commercial building electricity price, not end consumer like a private person, because that can be more complicated. In such a way, those kind of data is available. And of course, you do the more careful validation, because that's really affect the benefit, the cost analysis. So that's what we do. And we do the use national data and do the use of local results to validate the data. So that's the work has been working for about half a year. But it's very interesting. I would like to also, if there are students here, this work is mainly work by one of the students. She is not from engineering background, rather than I think from the administration, because she's in another field. And this paper is her first journal publication. So it's possible if you have a good question, and also you really work and study a little bit more in detail. Of course, she was lucky, and just this is very important, and she picked up the question and do the. She just graduated, 2 or 3 months ago.
Okay. Well, great. Well, thanks very much. So I think we have come to the end of the Q&A session. So now can I pass the microphone back to Professor Oak? Yeah.
Yeah. Thank you very much, Professor Wang. So just let me bring Paul, our volunteer freshman student, to give our concluding remarks.
Thank you everyone so much. This is the end of the 6th session of the Global Lecture Series. I would like to extend my sincere gratitude and appreciation to Professor Yan for your valuable contribution and for sharing your knowledge with us during your busy schedules. I also extend my special thanks to Professor Yongchibok for organizing this wonderful event. Thank you all the panelists, the program leader, and all the participants for attending this wonderful event and bringing your expertise to this gathering. Thank you again, and have a wonderful day.
Thank you, Professor Yan. Thank you, Professor Wang, and thank you for your school. Have a great day. Bye-bye.
Yeah, have a great day. Bye-bye.